Hello AAT, we're on section 4.5. This is the second part. We're finishing up on solving radical equations. So we're on I here. 9 plus 5 times the cube root of 2m equals 29. So a cube root means that you're going to have to cube both sides, but first make sure you find that radical, and isolate it. So I want to subtract the 9 to both sides. And I got 5 times the cube root of 2m equals 20. Okay, so I talked on the previous video about how if you have a coefficient in front of the radical, you can go ahead and square or cube both sides at this point. However, 20 is easily divisible by 5. So I'm like, why not go ahead and get rid of that 5 by dividing both sides? Because this is multiplication, so the inverse operation is just dividing both sides by 5. And so I end up really isolating that cube root of 2m equals 4. So be careful. Remember, you are cube rooting, so you need to make sure you cube both sides. And I end up, if I cube a cube root, I just have 2m. And this would be 4 times 4 times 4. Write it out if you're not sure. You really should have 4 cubed memorized. 4 cubed is 64. And then we just divide by 2, and m is 32. Now, you don't have to check cube roots. You will not have extraneous solutions on cube roots because cube roots can have negative or positive answers. If you cube something, you can still have a negative. So it's not a bad idea to check it anyways, just to make sure you didn't make some mistake. But cube roots will not have extraneous solutions. So I could just check it by plugging it in to see if that I did everything right, or I could go back through my work, but there's no reason to look for extraneous solutions. So J, our radical is already alone, so I'm going to get rid of that cube root by cubing both sides here. So x plus 6 squared, the radicand. You still need that square though. We cubed to get rid of the cube root. 4 cubed, we already said, was 64. So now we have a square root. This is kind of like completing the square. We could either FOIL those out, or we could square root both sides. I would prefer to square root both sides because a 64 is a nice, easy thing to take a square root of, but you gotta be careful when you square root both sides. You have to put a plus or minus in front of what you're square rooting. So if I square root both sides, I'd have, I'm gonna put a big square root over here so we can show what we've done. Gotta put a plus and minus in front of that 64, because the square root of 64 is not just 8, it's also negative 8. So I get two problems. I get x plus 6 equals 8, and x plus 6 equals negative 8. So here I solve, and I get x equals 2. And here I solve, and I get x equals negative 14. It was a cube root, so I don't have to check for those extraneous solutions. Make sure if you square root both sides, you got to have the plus and the minus. Okay, K. This one's kind of weird because it's got a cube and a square root. But that's very similar to what we had here. This is a 2/3. We could have written this one back here as x plus 6 to the 2/3. And so the root is the denominator. That's what we did to both sides. So if it helps you, you can write this as power over root first, but we know we've got to get that isolated. So I'm going to go ahead and subtract 10 from both sides. And I get negative 64 equals negative m minus 10 to the 3/2. And I don't like that negative, so I'm going to divide both sides by a negative 1. And I get 64 equals m minus 10 to the 3/2. So if you would prefer to write this as the square root of m minus 10 cubed, you can, but make sure it's power of a root. It's a square root, the power is 3. And then I can see that I would square both sides, or you can see by squaring both sides, an exponent to an exponent, you multiply these and you just end up with the cube anyways, because that's like a 2/1 and those 2's would cancel. So we'd end up with m minus 10 to the 3rd by getting rid of the square root. We'd just be left with the m minus 10 to the 3rd. Okay, equals now, but we got to square 64. Okay, so I'm just not going to square that right now. I'm going to keep that as 64 squared because, yuck, I don't want to square 64. But let's see what happens. How do we get rid of a cube? We're going to cube root both sides. So cube root both sides, or if you cube a cube root, okay, so I have cubing a cube root, or cube rooting a cube, I just have m minus 10. But here, this is 64 to the 2/3, or 64 squared cube rooted. And the good thing about fractional exponents, power of a root, you can do either one first. I can do the 64 cube rooted and then square it, or I can square it and then cube root it. I don't want to do 64 times 64, so I'm going to cube root it first. 64 cube rooted is 4, and then square it, bringing that m minus 10 along. So 4 squared is 16. That makes it much easier. 16 equals m minus 10. Add 10 to both sides. And m equals, what's that, 26. Okay, so last problem. We want to isolate this root. So I'm going to subtract 2 from both sides. And I'm going to write this as a fractional exponent just to kind of show you this a different way. If I have x plus 2 power of a root, this would be to the 4/3 equals 18 minus 2 is 16. So if you look at what we did here, we ended up squaring both sides and cube rooting both sides. So early on, if I had taken this power of a root and flipped it, meaning I did 64 to the 2/3, I could have kind of done it all in one step if I'd flipped that exponent as the 2/3 to the other side. So I'm going to try to do that instead of making this into 2 steps. Why not do everything to the 3/4? So x plus 2 to the 4/3 to the 3/4, you can see all those fractions, multiplying fractions would cancel, and you just have x plus 2 because you're 4th rooting it and cubing it. So we're going to do 16 to the 3/4. So that means the 4th root of 16 cubed, and I can do either one first. Well, the 4th root of 16, 16 is 2 times 2 times 2 times 2. So the 4th root of 16 is 2. And then 2 cubed is 8. So subtract 2, and x is 6. Okay, so now let's look at this. On this, when I did it to the 4/3, that means I did the 4th root and I had to cube root it. So if I do the 4th root of both sides, I need to make sure I do a plus or minus. So this is plus or minus 8. So this is the answer I got with a -8, and I also have x plus 2 equals -8. Subtract 2 from both sides, and so my second answer would be -10. So 2 answers. Make sure if you have an even root that you include the plus or minus. Okay, go practice.